All right, well, I'll get started. We have two more panelists that hopefully are going to be joining us this evening, but I'll get things rolling and hopefully they roll in at some point. So my name is Matthew Watkins. I am the current chair of the Sustainability Commission here in Rossland, and I'm part of the Energy Task Force team that is putting on these talks. I'd like to start by acknowledging that we're hosting this event from the traditional territories of the Sinaks, the Salix, the Silkwepum, and the Tunahas people. It's important to recognize where we are and the impact of us being here has had on local peoples. I also came across something that I think is worth sharing. Our local buy and sell bubble, when you log in and you go up to the top here, everybody should be able to see this. They've done a very good job of acknowledging where we are, and they've also put together a list of links and resources for people if you want to do a little bit more reading. The one that I found that was very interesting was the Kootenai Co-op Radio Synax Stories. It's a series of podcasts that's easy to consume and super informative. So I'd recommend that to anybody that's interested. So for those of you who are joining us for the first time tonight, tonight's presentation is part of a series of 6 presentations we're doing over this winter, all focusing on home energy retrofits. So you can see we did an introduction to home energy retrofits. We've done energy assessments and behaviors, doing air tightness and ventilation tonight, and then 3 more coming up this spring, finishing off with a deep dive into 2 local deep energy retrofits that have happened here in Rossland. The aim of this series is to introduce homeowners to a full suite of issues and considerations when you're thinking about and undertaking home energy retrofits. By drawing on expert knowledge and local experience, we hope to give people as much perspective as possible. There's going to be a wide range of knowledge amongst attendees, so we're walking a bit of a fine line between going too in-depth and being a bit too high level. So if you find it too in-depth and something goes over your head, don't hesitate to send me an email with a question. I'm happy to reiterate it or reframe it or try to get an answer to you. If it's too high level, I'm going to follow up every presentation with a package of resources, links and documents that should allow you to dive pretty deep, or at least get you into the rabbit hole, and then you can find your own way from there. I'd like to give a big thanks to the Energy Task Force team, Ken Holmes and Margot Lohr, for helping me put together tonight's presentation. We also encourage any feedback you have. So if you have ideas, comments, questions, our contacts are below here, email, Facebook, and webpage. Yeah, we encourage you to get in touch. So tonight's talk, we're going to be looking at air tightness and ventilation in home energy retrofits. We're going to start off by reviewing some of the frameworks of how to think about home energy retrofits that I talked about in the previous presentation. And then we're going to cover air tightness, ventilation, and finally we're going to open it up to Q&A. And we've got Francois Pouliot here to help us with that, who is a certified passive house tradesperson. He's also a Red Seal carpenter and owner of FP Designs here in town, design and construction. Robert Stupka hasn't signed in yet, but he was going to join us. He's a certified passive house designer, professional engineer, and project manager with Fortis. And then we have Ken Holmes, who's a retired professional engineer and certified energy manager and longstanding local energy guru. So they'll be on hand to help with the Q&A, which will be great. So getting into it here, just a review of why this is of interest to us. As Canadians, we've got amongst the highest per capita carbon footprints in the world. Housing, as you can see from this graph, is the second largest source of this footprint. 87% of the home's energy footprint or carbon footprint, sorry, is from its maintenance, or not maintenance, sorry, from its operations. So there's a significant percentage of our housing footprint that is up for grabs in terms of reduction. The vast majority of us here in BC are burning natural gas for heat. The average detached home in BC produces about 2 tons of carbon emissions by burning that natural gas. So getting off natural gas can cut your personal footprint by 15%, which is a great start. Combine that with a few other things, getting an EV, modifying your diet, and you can make a big chunk, cut a big chunk of your personal emissions in no time. So one of the frameworks that's important to think about when you're planning and undertaking a home energy retrofit is the importance of finding synergistic low carbon solutions to the various motivations behind your retrofit. So there's lots of reasons why you might want to take a home energy retrofit. Climate change mitigation, that's reducing your carbon footprint. Adaptation, so making your home more resilient to pending climate change. Making it healthier for occupants. And there's going to be solutions that find commonality between all those goals. And when you're thinking about it, you want to try to find that commonality as best you can. The energy efficiency pyramid is another important framework to keep in mind. So this pyramid demonstrates how moving up it increases complexity and cost of intervention or action. So with this series of talks, we're starting at the bottom, starting with the cheapest, easiest, and arguably most important stuff, and moving our way up. So you can see tonight we're covering air sealing. They've got it on different levels here, but we're covering air sealing and ventilation. So we're moving our way up the pyramid. Another important thing to keep in mind is that your house is a system and is a pretty complex system at that. So any modification to any one component is going to have knock-on effects, and we want to ensure that there are no unintended knock-on effects. So we want to think through the process and think about the possible knock-on effects and make sure we've accounted for those in our retrofit plan so that there's no major problems spring up. All right, so getting into airtightness. Build it right, build it tight. So restricting the passive movement of air through a home's envelope is one of the most important functions of a building enclosure. There are 2 main factors affecting air leakage in a home. The first are the number and the size of the holes in a home. So if you think about gaps around doors, around windows, physical holes in the air barrier, all of these add up or can add up to quite significant surface areas in a home. So Ken Holmes actually sent me this the other day. This is from Natural Resources Canada and is a visualization of just how big those holes can add up to. So a pre-1950s home, the combined surface area of the average holes or the holes in the average home from pre-1940 is going to add up to a circle with a diameter of 50 centimeters. So that's a decent sized window that you've got open in your house 24/7, 365. As you can see, that hole gets smaller and smaller with the years and as building efficiencies increase and airtightness of those homes increase. And we get down to an R2000 home, which is a fairly efficient home, and that still has a 20 centimeter hole, diameter hole in the side of the house. So another factor affecting airflow through a home is the difference in air pressure between the inside and the outside. So there are three factors that affect this difference in air pressure. The first is what's called stack effect, which is basically warm air in the home rising up and creating pressure on the ceiling and upper walls and pushing against those walls and finding those holes and those cracks and pushing through the envelope. And as it does so, it creates negative pressure in the lower part of the house and sucks, in the winter, cold air in through any gaps and cracks in the lower part of the house to fill that void, bringing in a lot of cold air and possible contaminants into your home. The second factor affecting this pressure differential are mechanical systems. So if you think about any fans you have in your house, your range hood, your bathroom fan, even your fireplace or your dryer, every time you turn those on, they're pulling air from inside your house and pushing it out of your house. This decreases the air volume in the house, depressurizes it, and again, creates an incentive for air from outside to be pushing into the house to fill that void. The third factor affecting pressure of the home is wind. So as wind goes over a home, it's hitting one side of the house. And so you can think about air pushing inside the house and finding those holes in the cracks. What it's also doing as it wraps around the house is it's creating negative pressure on the far side of the house. And that is actually pulling air from inside the house outside. So you've got a push on the windward side and a pull on the leeward side. And those three factors, along with the holes, can create a significant amount of air leakage through a home. So this slide highlights some of the critical functions and the critical barriers that, so critical functions of the wall and then the critical barriers used in the construction of a wall to address or to provide those functions. So looking at tonight, we're looking at air barrier systems. And as you can see, this is a bit of a reminder of the home as a system, because you can see that how air barriers relate to all of these different control functions. You got very strong relations to air, heat, and vapor, and then weaker relations to water, sound, and fire. So why do we care about air tightness in a home? Doing research for this, I read a good analogy that compared insulation to a wool sweater, and that a wool sweater is great when the air isn't moving. You get into the wind with a wool sweater on, and its effectiveness at keeping you warm diminishes quickly. And so insulation on a home is very similar. You can wrap your house in a lot of insulation, but if there's no air barrier and air is just moving through that insulation as it wills, then that insulation isn't going to be doing you much good. According to the US EPA, air leakage accounts for between 25 and 40% of energy used for heating and cooling in a typical residence. So that's a big deal. Here, this is a graph from that visualization from Natural Resources Canada that I had earlier. And you can see here the big difference in cost associated with air leakage of different era homes. So, I've got a 1960 home heating with natural gas. I'm dumping $360 out the window every winter, which is not insignificant. Another important reason we care about air barriers is moisture movement within the home. So inside your home is hot. Hot air holds more moisture than cold air. As that air moves through your envelope, if there's no air barrier, and moves towards the exterior of your home through the processes we described earlier, it's going to cool as it hits near the exterior of that home. And as that air cools, its ability to hold moisture is going to drop, and that moisture is going to end up condensing on surfaces. This can cause serious damage. You can get mold, and you can get significant rot. So this actually can be a significant factor in damage to a home. This is a visualization of how important air is in moving moisture. We often think about vapor barriers. So a lot of people will know about vapor barriers, the desire to reduce the vapor moving through a wall, but it's actually air is the primary thing that you want to be stopping moving through a wall for moisture damage, just because of the volume of water that can pass through a hole when air is moving through it versus just vapor diffusion through it. So a third reason that we care about air barriers is for comfort and health. So from a comfort perspective, drafts, anybody been sitting on the couch watching Netflix and feels that cold air blowing across them can understand how that's going to affect your comfort. So drafts is a big one. Another one is stratification of air. With the free flow of air through a home, you're going to get more likely that hot air is going to rise and cold air is going to fill in behind it, like we described. And so you're going to get different floors are going to be different temperatures, different comforts. So people upstairs can be too hot, people downstairs can be too cold. It can even happen on the same floor where, at head height or at thermostat height, it's a decent temperature. You sit down on the couch and it's a completely different temperature. Health-wise, there's two things. So if you think about exterior air quality, often quite good where we are, except in forest fire season. And it's not infrequent that, we have advisories that children shouldn't play outdoors, and that, according to projections, that's only going to increase. So the ability to have a good air barrier and keep that smoke from entering your home is going to increase occupant health. What was the other one? There's indoor air quality issues as well. We're going to talk about that with ventilation. Oh, that was the other point. So as air moves through your envelope, it can also pull particulate matter, not just particulate matter that's outside, like smoke, but particulate matter that's in your walls. So if you've got, depending on when your home was built, who knows what's made up of that insulation, what kind of particulate matter is in there, that can end up in your indoor airspace and affect occupant health. So there are a few key features of a good air barrier. So the first one is continuity. So this basically is the idea that there's an air barrier everywhere. And there's a good sort of rule of thumb that I like, is that if you take a cross-section of your home, like this picture here, you should be able to take your finger and trace the air barrier all the way around your house without lifting your finger. So that means that it's continuous and every aspect of your home has an effective air barrier on it. There are two critical things to keep in mind when trying to achieve this continuity. First is the details, and details really matter when it comes to air barriers. Details refer to all of the sort of challenging points within a home where the air barrier needs to sort of change how it is applied. So you can think about around a window. You have a wall, you've got air barrier all the way up the wall, and then it encounters a window. How's that air barrier going to interact with that window to ensure that it seals nicely and ensures that continuity? So from this picture sort of highlights some of the difficult areas that you might encounter when you're installing an air barrier. And you can see that there's no shortage of areas that you're going to have to think through very closely to figure out just how you're going to transition between those. This is just an example of a detail a cross-section detail. And as you can see, things get pretty complicated pretty quickly. And there's a reason for it, because there's a bunch of different outcomes that are trying to be controlled for. And air barrier is one of those that needs to be worked into the details. Another important thing with continuity is the process through which your air barrier is applied. So you'll want to think through very closely when and how your air barrier is going up during the retrofit process. So if you put that air barrier up too early, then it can be in the way of other things going on in the construction site, can be damaged. You might have to cut into it to accommodate something else. Anytime you cut into an air barrier, it's a bad thing. Your ability to repair that is not 100%. If you put it in too late in the renovation process, you might have to be working around more details. So features that might not have been there that you might have been able to get the air barrier in before, and how to clean it or finish. So you just want to think about the process in which the air barrier fits in to the rest of the renovation project. And yeah, that's an important part in continuity. So impermeability is pretty straightforward. Your air barrier has got to be a barrier. So there's different types of air barriers. Get more complex, you get smart air barriers that can let vapor through one way, vapor through both ways. But the commonality is that they don't let air through. So this is both for the individual components of the air barrier as well as the air barrier as a system. So there are a lot of different components of an air barrier. There's sill seal, wall sheeting, house wrap, contractor's tape, caulking, gaskets, windows, drywall, and weather stripping are all sort of different elements that and materials that work together to create an air barrier system. And so you need to make sure that individually and then as a group, they are impermeable. One of the important things to think about here is that there's been great advances in air membranes in recent times. So a lot of technology is going into these air barriers, and quite often the accessories are very tightly related to the air barrier. So often they'll be proprietary. So if you buy an air barrier from a company, they're going to have a very, very specific tape that you need to use for very specific applications of that air barrier. If you're not using that tape, then that system is not airtight. And so your tape might be airtight, your air barrier might be airtight, but together as a system, they won't be. So you need to pay close attention to how those components fit together and whether or not they're recommended to be used together. So durability is another key feature. This, makes pretty good sense. Your air barrier needs to be both durable enough to withstand the construction process, and it also needs to be durable enough to provide some longevity. So it needs to be weather resistant and just life resistant in order to provide you that air barrier for the expected life of the home. This is sort of back to impermeability as well. Those tapes, they've come a long way in the different types of tapes that are being used. And that durability is often dependent on adhesives that are used. They're often a weak variable in the system. And so they can often affect long-term durability of the system as well. So there are a few different ways of approaching. Actually, just a quick comment. Assessing. I didn't cover assessments of existing air barriers in this talk because I talked about it in the last talk. But naturally, in this process, you're going to want to figure out what kind of quality your existing air barrier is in, and pinpoint where the problems are. And that's covered in the previous talk. So once you've done that and you want to move forward with addressing these holes in your air barrier, there's a few options that you can take. So this is a little infograph from the U.S. Department of Energy that shows some of the common areas of weakness in a home's existing envelope. Attic hatches, doorways, windows, any sort of electrical or plumbing outlet going or conduit going through the wall is going to be a weakness as well. So the cheapest and debatable whether or not it's the easiest approach is to patch your existing air barrier. So there are some very easy ways in which you can get started with this. Things such as electrical outlets, flanges. They're basically these little foam inserts that you can put into your electrical outlets, which are a common source of air leakage, to seal those up. Weather stripping around windows and doors is another easy approach to patching your existing air barrier. Drywall is another one. So, if you got major cracks in your drywall, patching those up will help with your air barrier. Cracks in your foundation, same thing. So basically, yeah, patching your existing air barrier. This is an example here of a detailed approach to taking to drop ceilings. So this comes from Best Practice Guides for Air Sealing and Insulation Retrofits from BC Housing. And this guide goes through in good visual detail a lot of the different ways in which you can patch existing air barriers. I won't go through those here, but if this is the approach that you're taking, I would recommend starting with this guide. It gives very good examples, very good visuals, and detailed explanations of different approaches that can be taken to patch existing air barriers. A downside to this approach is that it's very, very difficult to use this approach to get to modern construction air tightness levels. It's just, yeah, there's a lot of details. You're working around a lot of existing aspects of your home and just trying to sort of do the best that you can instead of starting fresh. So your likelihood of getting this home as tight as modern new constructions is very low. So another approach that can be taken to air barrier retrofits is installing a new air barrier on the interior of the home. And so here, there's many different approaches to doing this. And there's quite a bit of building science that goes around the applicability of these different types of approaches. So this type of retrofit, I would highly recommend involving a professional in at least the design of it to make sure that your air barrier is appropriately placed within the thermal envelope of your wall, to make sure that you're not going to be running into water vapor management issues, so condensation. So that, yeah, so consult a professional on these approaches. The one shown here, so interior new air barrier, is basically, it can be done a few different ways, but removing all your interior drywall, assessing the existing insulation within your existing wall. So maybe it's good, maybe it's not, topping it up, completely replacing it, and then putting up a new air barrier, building a new stud wall on the inside of the existing wall, and then filling that cavity with insulation, putting up new drywall. So there are a few downsides to this approach for sure. The most significant one is occupant comfort. So this is a pretty hard approach to take while living in the home. You can imagine that it'd be very disruptive. Second thing to think about in some of the old smaller Roslyn homes is that you are cutting into your existing square footage. So by building a new wall on the inside of your existing wall, you might think it's only a few inches, but you apply that around the entire perimeter of your home, and you can be seeing a lot of a reduction in square footage. A benefit to it, so another downside is that by opening up older walls, you are increasing the possibility of being exposed to hazardous materials. So there's a lot of materials that were used for insulation in the past that have to be managed by specialists. Asbestos can have significant health impacts, and so this approach increases, depending on exactly how you do this, but often you're going to increase the odds that you're going to have to address some of these materials. A benefit of this approach is that by putting your air barrier, by putting a new stud wall on the inside of your air barrier, you can run all your services. It becomes a service cavity that you run all your electrical and your plumbing through. And by doing that, you're eliminating all the penetrations into that air barrier that would normally exist. So if you think about your outlets, like standard construction, most of our homes is going to be that every outlet is a penetration in our air barrier. All of our plumbing fixtures running through an air barrier. And so if you can reduce the number of times you have to penetrate your air barrier, you're greatly increasing the odds that you're going to achieve a nice airtight home. The more times you puncture it, the less likely you're going to achieve that airtightness. Another approach is to put a new exterior air barrier on your home. So again, there are various ways in which this can be done, but in general, it involves wrapping the exterior of your home in a new air barrier. So sometimes this can be on top of existing siding. Sometimes the existing siding needs to come off. But you're wrapping the house in an air barrier, and then you're putting insulation on the outboard side of that air barrier, and then putting siding back, or your weather barrier, WRB, and then your siding back on top of that. Some upsides to this approach are that you're working on the exterior home instead of the inside. So this approach can often be taken while people are living in the home, depending on what else is involved in the retrofit, but there's less disturbance to the occupants. You're not taking up any interior square footage of the home with this retrofit, and you're less likely to open up cavities with materials that you need to move and therefore be careful with. So you're kind of keeping existing insulation and materials in your home in place, and then just adding things to the outside of your home. Downsides to this is that it's, I would say, the most expensive approach of these three. And for some homes in Roslyn's, this adding, an extra foot onto the side of your house is not going to be possible because of property boundaries. So we've got some interesting property boundaries here in Roslyn, and some homes are awfully close to theirs, and that's something important to think about before you do it. Yeah. So the benefit to these last two approaches is, first of all, both of these last two approaches are usually associated with what we call deep energy retrofits. So, very significant retrofits to an existing home to get its energy use down to something close to zero for heating. So they're major projects. They should be done in coordination with other aspects of a retrofit. So if you're going to be undertaking these last two options, you're going to want to be doing it at the same time that you're doing your windows, for example. So they're bigger projects that want to be coordinated with other aspects of a home energy retrofit very closely. A big upside to them is that you're working with modern materials and modern techniques. So your ability to get these homes very tight with these two approaches is much higher than with the first approach of patching your existing air barrier. So that's a bit of a whirlwind of airtightness and how we can approach it. There's a lot of different ways to do it, especially with those last two approaches. Francois has a lot of experience with this. Ken, I'm sure, has some things to say about these approaches and the pros and cons too. So they're going to be joining us in the Q&A at the end, and I'm sure I'll be happy to talk about their preferences and some things to think about with the various options here. All right, moving into ventilation. So build it tight, ventilate it right. So a tight house is better than a leaky house with a caveat. The tight house needs to be ventilated. So we talked about all that passive ventilation going through that old leaky home with the big 40-centimeter hole in it. When you seal that up, if you don't address the ventilation side of it, you can run into serious indoor issues if you don't have those air exchanges. The preferred way to get these air exchanges in a home is through what's called a balanced mechanical ventilation. Basically, balanced mechanical ventilation is controlling air coming in and at the same time controlling air going out. So it can control the pressure of your home and thereby reduce those effects of pressure of air leakage, and can also change over the air in your home for the occupants. So there's two main reasons we want this ventilation. One of the main ones is moisture control. So if you, as humans breathing, cooking, living, we produce a lot of moisture. I don't have the stat in front of me. It's a large volume of water that we produce on a daily basis. And if this isn't brought out of the house, it's going to lead to serious structural issues. So same thing with air leaking through your walls. Moisture buildup can lead to all sorts of mold damage and rot and destruction in your home. It's also associated with occupant health. So there are ideal levels of relative humidity in a home that want to be achieved, and without mechanical ventilation in a tight home, you're going to run into issues around the health side of things too. So a big issue, health and comfort. So the big one I want to touch on here is depressurization of a home and what its impacts can be on combustion exhaust in a home. So this infographic here shows, you've got your dryer on, you've got your range hood on, and you've got your bathroom fan on. You've recently sealed up your home. It's nice and airtight. By pulling all that air out and not having a way for air to come in now because it's nice and sealed, you run the serious and deadly risk of backdrafting any exhausting mechanical you have in your home. So older furnaces, fireplaces, hot water heaters, anything that's burning natural gas for heat. When you depressurize your home, you can quickly fill your home with carbon monoxide, and people die of this not infrequently. So it's a very, very important thing to keep in mind when you're sealing up that house, is to have a plan for mechanical ventilation as well. So there are a few approaches that can be taken to balance mechanical ventilation. The first approach is central recirculating ventilation. So this is basically two fans, one pulling air into your home and one pushing air out of your home at the same rate. This is a bit of a simplified diagram. Usually these will be connected to multiple rooms and will have a way of buffering the cold air that's coming in. So it's not coming in, it's coming in a little bit warmer than just outside air. But this is one of the most basic ways of getting ventilation in a balanced way into a home. Another way is very similar, except it uses your furnace to pull that air in and distribute it. So you'll have an exterior air input that comes into your air return in your furnace, goes into your furnace, gets pushed throughout the house along with the hot air. So again, it gets warmed up a little bit, so it's not an exterior temperature. And then you have another fan that's pulling air out at the same rate that's pulling air in. So the third and by far most preferred route to go is with a heat recovery ventilator. So a heat recovery ventilator is basically an energy exchanger. So it's pushing stale, warm air from inside the house out and pulling in cold, fresh air from outside the house in. And it's pushing those two airs past each other and picking up heat from the warm interior air and transferring it to the cold, fresh air. And so it's doing the same thing as the CRV, except it's pulling all that energy, or not all of it, but a significant percentage of the energy that has gone into heating your home and making sure that is transferred to the fresh air that's coming in. So they're much more energy efficient or in terms of heating a home than the other two options in balanced ventilation. Here's some modeling of the energy savings for an HRV compared to other continuous balanced ventilation approaches, so forced air and central recirculating. And so we're heating degree days, we're in the Ken can correct me if I'm wrong, but we're in the 4,000s, I believe. And so you can see you've got an annual, $120 that this HRV is saving you in terms of energy savings by transferring that heat into the incoming cool, fresh air. So when looking at HRVs, there's three key features to keep in mind. One is the airflow rate. So there are minimum airflow rates set out by the BC Building Code, and HRVs will have different capacities. So you'll have sort of apartment size HRVs, you'll have medium house, large house, mansion size HRVs. And so when you're looking at an HRV, you need to make sure that its capacity meets your minimum airflow needs. Another important feature of HRVs is the rate at which it's able to transfer that heat from the outgoing warm air into the cold air coming in. And there's a wide range. There's a minimum efficiency rate of 60 that's required in new builds. That goes all the way up to, here we have a Zendar at 88%. So there's a wide range of efficiency that you get here. And basically, the more efficient, the less heat you're losing going out your walls or going out your heat recovery ventilator. The efficiency is directly correlated to cost. So on the lower end, you're looking at HRVs, $900 to $1,000 for the units. Those are going to be down around 60%. This Zendar is going to be closer to, what was the quote? It was around 4 or 5 just for the units, just for the HRV unit. So there's a significant cost difference there in their ability to recover that heat. Another consideration is operational efficiency. So this is basically just the amount of electricity needed to run the unit. And again, there's going to be differences in the efficiencies of these different HRVs. So it's something to look at and something to consider. Sometimes getting a smaller HRV is going to have to be running harder in order to service your home, and it's going to be drawing more watts, whereas getting a bigger HRV might be a little bit more expensive, but you can actually throttle it down and run it at an easier pace for the unit, and it'll draw less electricity. So there's sort of a balance there to look at when you're choosing one. There are two main ways that HRVs can be retrofitted into homes. The first and easiest is to hook your HRV up to your existing furnace ductwork. So this obviously only works if you have existing ductwork. So if you have a natural gas furnace in your home, this is an option that you can take. And you're basically using the air handler, using the furnace, and to push the fresh air through the home and its ductwork. So a big upside to this is that it's easy. So that infrastructure already exists in your home, and you're just tapping into that, which makes it easy. With that ease comes cost benefits. So it's much cheaper to install than the alternative that I'll talk about in a second. There are a couple downsides to this approach. So the biggest one is that this requires your furnace fan to be running 24/7. The HRV fans aren't strong enough to be able to push the HRV air through the larger ductwork of your HVAC system. And so they require your HVAC fan to be running. And it doesn't need to be heating all the time, but that fan needs to be running. And that fan uses a lot of energy compared to the HVAC fans. And so that's a downside to this, is that it is more expensive to operate, cheaper to install, more expensive to operate than a dedicated HRV system. The second downside is that sort of the optimum distribution of fresh air and extraction of stale air is a bit different than the optimum distribution of hot air. So by tapping into your furnace infrastructure, you're putting air into where it's best that hot air is, not necessarily where it's best that fresh air is. That is a bit of a smaller problem, but is something to think about. The other approach is to have a dedicated HRV. This infographic has an HRV in the attic. That's not, depending on how you insulate your attic, that's not normally where we'd put it. But a dedicated HRV is going to have dedicated ductwork servicing it. So from a retrofit perspective, this basically means that you're installing a whole new set of ductwork through your entire house, basically into every room. So a big downside to this is that it increases the cost and difficulty of the retrofit in terms of the installation. So you have the material cost of all that ductwork, and you have the labor costs of opening up all your walls and installing that ductwork. The main upside to this, which I already went over with the integrated furnace approach, is basically that the HRV fans are much more energy efficient, and because they use smaller ductwork, they're powerful enough to distribute that air through your house, using much less energy to operate, and you get to put this air where you want it. So, you know, a furnace doesn't often have a return feed in your washroom. Your HRV will have a return, so you'll be pulling, you know, stale, moist air out of your washroom back into your HRV unit, and you're putting fresh air into living spaces and sleeping spaces such as your bedroom. So it allows you to optimize sort of that extraction and input better than the furnace integrated approach. This graph shows the energy cost, the creative energy use of the 4 different approaches. So, you know, the forced air furnace and the central recirculating ventilation were the 2 other balanced ventilation approaches I talked about earlier. And then in the middle, you have the forced air furnace with an HRV, and then you have the independent HRV. So you can see between the 2 HRVs, there's the same ventilated heat energy between the 2 approaches, but you're using 1/3 the amount of electricity to run an independent HRV than you are to running your furnace fan all the time. So there are 2 main ways. So this is for the dedicated HRV approach. There's 2 main ways of installing your ductwork. One is called a trunk and branch. So this is when you think about existing HVAC ductwork in your house, this is usually what you'll see, where you'll see a large piece of duct coming off your furnace, and then it gradually gets smaller and smaller with smaller pieces of duct coming off of it. So that's called the trunk and branch approach. Some benefit to the trunk and branch is material cost. So the material of this type of ductwork is relatively cheaper compared to the alternative. Big downside is that it involves more work. So if you're hiring out, there's a lot more labor involved in this process. And if you're doing it in-house, there's a lot more skill involved. First with the planning, so all those ducts need to be sized appropriately, and there's not complicated, but there are calculations that need to be taken to figure out the optimal duct size to ensure that the air pressure is correct going into each of the rooms. So that needs to be undertaken. And then the fittings and all the different aspects that go into working the tin, essentially. Like, so it's more labor intensive to take this approach. An alternative is what's called a home run approach, and this basically has a dedicated duct running from every HRV outlet and inlet, home running all the way back to the HRV unit. So the major benefit to this is that it's a lot easier to work with. So yeah, these ducts are usually flexible. They don't involve the tin work. They're usually under 3.5 inches, so they'll fit in existing walls, whereas the previous trunk and branch approach, that those ducts might not necessarily fit in the wall, whereas often these ones will fit in the wall. So from a labor installation perspective, this is a much easier and much faster and much more DIY friendly approach to installing an HRV. The main downside to this approach is the expense. So the cost of this type of ductwork is significantly more expensive than the tin you'd be using to do a trunk and branch approach. I've got a quote on my place, and so 2,300 square feet using this approach, proprietary materials, was going to cost $3,000 just for the distribution. So that's outside of the HRV. That's just for the distribution. So that, depending on where you're at, how much time you have, how much skill you have, how much money you have, those are different things to think about. And I'll send this out as well after the presentation, but this is another guide put together by, I think it's BC Homes. I've got it covered up here. Yeah, a few different government organizations that walks you through heat recovery ventilation for homes. So it covers new builds and retrofits, and it covers everything I covered in this presentation plus a lot more. So if you're thinking of taking this on as a DIY, I'd highly recommend starting with this document. All right, so that was a crash course in airtightness and ventilation. Yeah, obviously a lot more detail to get into if this is something that you're going to be diving into yourself. Tonight, so we didn't get Robert, but tonight we've got Francois Poilette and Ken Holmes with us. I know Francois has experience with both the airtightness retrofit as well as the HRV, and I have no doubt that Ken has experience with both of those things as well, and some thoughts on those matters. So we're going to do something a little bit different tonight. And if are you with us, Margot? Yeah. So Margot's going to basically give you the option as an attendee if you want to become a panelist. And this will basically just turn it into sort of a meeting format so that we all have a face and a voice if we want to ask questions. So Margot's going to go ahead and give you that option. And then, yeah, we'll open it up to questions. Anything people have on their mind about what I covered or what I didn't cover, or comments, questions, concerns. I'll just throw it over to Francois here for a second. Francois, if you want to introduce yourself to everybody, some of your experience with these types of retrofits, and any thoughts you had on any specific things I covered, just to kick us off. Yeah, you're on mute there, Francois.
Yeah, thank you, Matt, for inviting. Yeah, I just wanted to say you did an amazing job at covering all this material and so quick. There's obviously so much to talk about. And I appreciate mentioning that I have a lot of experience in this department. I do have some experience. I don't really feel I have lots, but I certainly dove into it quite a bit through COVID. Everybody was probably looking for something to do, and I was spending a lot of time at home, and I decided, hey, I should learn some new. And so I just decided to dive into Passive House and start taking courses. And I quickly realized how much I like it, how much, how interesting it was. And then I became a certified Passive House tradesperson through the process. And yeah, it's been really good. Been networking quite a bit with other builders as well that are certified. And, it's a really good network of people. And that's what makes it so interesting.
So for people that are that get over to the east side of Roslins on Columbia, Francois is working on Dirk's house, which is just at Park in Columbia, and has a big sign out front that they're doing a Passive House retrofit. So for those of you that have walked by that place, that's the project that Francois is working on, just to give you some reference. And Ken, do you want to introduce yourself and just comment on your experience with airtightness and ventilation, and sort of any comments, questions, concerns you had about what I covered?
I first got involved back in about 2005 when I decided to do some upgrades on my 1938 old leaky Rossland house. So I hired a home energy advisor who came in and did the energy modeling and so on. But the most important thing he did for me was to blow a door test. And I think with retrofits, it's very important to find out where your starting point is. And a blower door test tells you how good your house is or how bad your house is. And in my case, it was a question of how bad it was. The number of air changes per hour was about 15. If you compare that with modern standards, today's code, step 3 requires something like 2.5. So I was starting with about 15. But what I'd like to emphasize is that there's a law of diminishing returns. And it was very easy for me to go from 15 to about 8 in a matter of a couple of days, spending less than a couple of $100. And going from 15 to 8 saved me something like 24 gigajoules a year. But then if you look at going from 8 down to, say, 4, you can spend a lot of time, weeks and weeks, and probably thousands or tens of thousands of dollars. And I recently did an estimate to see what I would have to do to get down to less than 2 on that old house. And that took me into considerations of deep energy retrofits, which you referred to. You know, ripping all the siding off, putting on external air barriers and insulation. So that leads into $100,000 or more. So the key to me is deciding or finding out where is your starting point and how far are you prepared to go financially. You know, what is the payback, if there's any payback at all? For me to go to the deep energy retrofit, spending $100,000 or more, at today's energy prices, it could be like a 200-year payback. And at my age, I'm not looking at 200 years. So find out where you are now. How bad is your house? How good is your house? And how far do you want to go in improving it?
Yeah, that's a very good point. So we covered this a little bit in the previous 2 talks, but basically the foundation of the energy efficiency pyramid really is assessments and making sure that you take the time and energy to really figure out where your house is right now and figure out where its weaknesses are so that you can appropriately plan how you're going to address it. And with that planning, you can, you know, bring into account the resources that you have, how much money you want to spend on it, and just gives you a better picture of, yeah, when you want to be starting to try to tackle some of those diminishing returns and get down to a lower or to a tighter home. Francois's house with Dirk, what's how tight did you get that, Francois, in terms of air changes per hour?
Well, what we did is we used 2 different protocol for testing. So the first protocol that we've used was the R2000 standard protocol, and this one there was a little bit easier to achieve better airtightness, just because of the modeling. But on that one we got 0.57 air exchange per hour on that one. And then when we use the passive house protocol for testing, we end up with 0.77. So it's a little bit different with passive house. You have to remove all of your interior wall volume, which makes it quite a bit harder because you're obviously removing volume within your house.
Yeah.
So the calculation is different there.
Okay. And that, for clarity for everybody, that is a very deep energy retrofit. That's pulling a house down to its studs essentially. And Francois used sort of both approaches that I went over with the air barrier. They insulated both inside the air barrier and outside the air barrier. But because they did do the interior, their air barrier was on the inside. There was a lot of detailed work around sort of floor joists and any penetrations in the wall that required like very high attention to detail in order to make sure all those details were appropriately sealed. And that's not even the house. Have you had it tested since the windows? Yeah, that's right. They tested with the windows, but not drywall or siding.
Yeah, so you know, when you choose to go in that direction and you want to take on, you know, a project of this scale, I think before you close your wall with drywall and all your finishing, it's really key to, you know, invest some extra money and get your mid-construction blower door test, because you can really, target some of the weakness there, and you can fix them, and you can really work with those details before you move forward with drywalling and covering all of your work.
Right.
So it was, you know what, I think if you're gonna go to that extent, you know, you obviously you mentioned, Andy, that that it comes with obviously a lot of cost. It does come with a lot of cost, but it also comes with a lot of attention to detail, and you really need to have that personality for it. Not everybody wants to go that far in detailing. It's really extensive, and you need to have the personality for it. You need to be very patient.
Yeah, it was pretty interesting. I spent a couple of days working with Francois on Dirk's place this fall. Was it? Yeah. And it was interesting to see all the other trades that came on site and how baffled they were at the approach. Like, there's a real education process that had to be involved by the project manager to make sure that all the trades were very aware of what the air barrier was, and that if there was a chance of you coming close to it, Francois was there to supervise it. Because, you know, you get drywallers putting up drywall carelessly and screws going through places they shouldn't be going through, and all of a sudden you've done a lot of damage to an air barrier that you spent a lot of time and energy perfecting. One comment about the energy cost that Ken brought up, and Freya brought this up at a previous presentation. Two things. One is that you kind of need to think about these retrofits in multiple paybacks. So cost is a big one. If you're just trying to pencil this out as a return on investments, there's going to be some difficulty. One thing to think about when you're doing that is that energy costs in the future are expected to increase. So as we electrify, those costs are going to go up. So something to consider when you're doing just a return on investment calculation. Another thing is that occupant comfort, occupant health are two other important variables that you want to take into consideration when you're figuring out, what you want to do with your retrofit. Margot, were there any questions in the chat or the Q&A?
Yeah, so Ben Martin, this quick one, asked if there's anyone locally who does the blower door test. We did cover that a little bit more in our assessment presentation. It is posted on our Facebook page and website, but we had a panelist who was an energy efficiency expert there. Yeah, Bruce Edson, thank you for saying that's put, and there are rebates for that. I'm actually currently going through that process for my own home, looking into those. And yeah, he spoke on our last panel and gave a lot of great information there. And then we had
Sorry to interrupt. So Bruce is new to servicing our area, and is the only one really locally currently. And his booking time isn't actually very far in the future. When I was talking to him last week, he said he was kind of booking, 3 or 4 weeks out. So he's not totally swamped. So he's, you can get to him, and he can get to you in a relatively short order.
Mm-hmm. And if there is timing issues, I do know of someone in Roslyn who has got an energy advisor from Kelowna. I think they just weren't aware Bruce was in the area, but it does sound like there are services from outside the area that will come in as well. And then Matt, maybe I'll direct you to the Q&A. There's a little more of a specific question here.
So I'll just read this question out. We recently added R28 to blow in. We sealed points of entry first. Then I saw some sort of quote blanket material fabric to lay on top. What are your thoughts on these? So I'm assuming this is blown in attic insulation. And I personally have never heard of a blanket material to put on top of this. Ken or Francois, have you ever heard of that?
I haven't, no.
No, I haven't. Not on top, no.
Yeah, I'm not sure what the point of that would be. There's relatively little going on up there, so disturbance-wise of what you've blown in, I don't know what the benefit of that is. So we've got another question or comment here. One thing I found with having an HRV at my previous house was that during the smoky forest fire season, the air coming inside wasn't filtered. So we returned the HRV off. So a couple things on that. One, you don't want to turn, if you've got a sealed up house, you don't want to turn your HRV off. They're meant to run continuously 24/7, 365 for the reasons that I mentioned earlier. The forest fire thing, that's interesting. Usually the HRVs come with good filters and upgradable filters. So in my experience and understanding, that's usually something you can address at the filter. Yeah, that's my personal experience with them. But that's interesting that you ran into that problem, because that is one of the main reasons that they are promoted for sure. Any other questions there, Margo?
Not that I see. Anyone's welcome to raise their hand and ask, or just type in the Q&A.
Francois, can you talk a little bit about the planning process for Dirk's retrofits? I guess specifically how long a planning process it took to break ground on his reno?
Oh, actually, sorry, Matt, to interrupt. Yeah. Maybe we can loop back to this after. I was looking at the Q&A, but the chat actually has some questions here.
Okay.
Exterior retrofit with Roxol comfort board versus exterior frame addition with conventional insulation, ? I guess weighing in on the pros and cons.
Yeah, Francois has a favorite there, I would say. Dirk's place on Columbia is an exterior Roxol comfort board, 2 layers of that with screws going through those layers, holding them on with strapping, and then your siding going on top of that strapping. I think a major upside to that approach is that it's easier. And there's some questions around thermal bridging, which we'll talk about in the next lecture, but thermal bridging is basically the ability of energy to transfer from the outside into the inside, running through a solid surface. So if you think about a piece of wood that is exposed on the exterior home and runs right through your wall and is exposed in the interior home, that cold is going to run through that wood into the interior of your home. So that's thermal bridging. And so the Larson Truss, which is the exterior retrofit that I showed, has wooden I-beams of various sorts that you can use that go on the outside, and that wood presents as a problem in terms of thermal bridging, so as a consideration anyway, in terms of thermal bridging. And then with the Roxol, you're putting 8-inch screws through it, and those conduct energy as well. So I don't know the trade-off in terms of that side of it off the top of my head, but something to look into. Yeah, one of the benefits of doing a Larson Truss is you can use dense packed cellulose, which acts as a carbon sink. So it has a lower carbon footprint than using Roxol. Though Roxol has a much lower carbon footprint than using styrofoam. So yeah, I encourage you to, or that's good that you're looking at Roxol and not styrofoam.
So that question was asked by Andy. I'm just going to allow him to talk. I see you have your hand raised, Andy.
Yeah, I hadn't seen that truss system before, and when you showed it in the video in that slide, I thought, it looked more labor intensive. And whereas the Roxol, you know, being a solid panel, fairly easy to install and quick.
Yeah.
And the thermal bridging issue for me was another advantage. The Roxol seemed to be better from that standpoint.
Yeah, yeah, totally. Yeah, those are two things I would look at as well for sure. Francois, do you have any in your research? Why did you land on the Roxol?
Well, I think something to consider, Matt, and I think it's great that you're talking about the Larson Truss system, and I think, you know, some people are going that route. I think one thing you have to consider is if you're going to be doing that much outboard insulation, you really need to look deeper into your structural members, and really you may get into a situation where you're going to involve an engineer because you're adding a lot of material to the outside of your wall. You're creating some additional loads there. And the Larson Truss, for an example, it was more challenging to deal with those additional load, and we just didn't want to get too involved with a structural engineer on some of those components. So we just went with the Roxol, or Rockwool now, outboard insulation. So we did 2 layers of 3-inch all staggered joint, vertical and horizontal joint. And then we use screws, so structural screws every 16 on center, and we strap everything 16 on center as well. And we just felt that it's not a quick system. It's really time consuming to install. Some people think that it's quick, but if you're doing 2 layers staggered joint, and it gets really time consuming. Yeah, and it was just easier to install because you could follow the engineering specs through Rockwool for the amount of insulation you're putting on side of your wall, and you can just use the guide that allows you to do the installation without an engineer. So
Great.
we just felt that it was a good option.
Yeah. Andy?
No, that was good. I was just trying to figure out my lower hand raise hand function there, but
Yeah.
no, it makes sense, and thankfully I had the opportunity to do some work on Dirk's Place at the preliminary portion of it, but it's an amazing retrofit, and Francois has done an incredible work, and you know, to get it to take a 80 or 100-year-old home and turn it into that level of efficiency and integrity is pretty incredible. So it is a model for sure.
Yeah, I'm not just a model in Roslyn, but a model in Canada. There are not many passive retrofits in Canada. So it is quite impressive that they've gotten to where they have. And as I mentioned, we are going to do a deep dive into Dirk's Place in our final energy talk at the end of March. So we'll be looking in much more detail what exactly he did there. Any more questions from anybody?
Yeah, we do have a raised hand here, and then we have a few in the chat.
I can't see the raised hand, but go. Oh, there you are. Yeah, go ahead.
Hi there. So I just put in the chat, I guess, a link to the attic blanket or attic foil. So I had that original question where we had put the R28. We added extra insulation to our attic.
Right. Okay. Yeah, that's something I can. I'm going to look into it because I've never heard about it. And if I dig anything up, I can include that in my email that goes out. I'm going to send out a follow-up email to this with the documents I talked about and just some more resources for people to dive a little bit deeper. And I'll include what I can dig up on this because I've never heard of it, and I wouldn't want to speak on it without doing some research.
Great. Okay, thank you.
Yeah, absolutely.
So we have 2 more questions, it looks like, in the chat. One's from Chris. Question about HRVs. Roslyn's air can be smoky, forest fires, inefficient wood burning appliances. Are there HRVs that filtered outside air before bringing it into the house? What is this? Oh, and also what is the specified lifetime of the tapes used for air barriers? So Chris had 2 questions there.
So the HRVs and exterior air quality, we had somebody on that suggested that they turn their HRV off in the summer because they found that it was bringing in that smoke. I've never actually heard of that. My experience with HRVs is that there is a filtration system on that with sort of various options of how much you want to filter that air. Maybe the smoke, I just haven't had the experience with the level of smoke that we've had in Roslyn. But certainly with my experience and what you read about promoting HRVs is that is sort of a critical function that they're supposed to provide. So I would look into the filtration systems that the various HRVs offer. I'm sure with the higher end ones, they're going to give you more and better options on the filtration side, which would be something to consider if, installing it here in Roslyn for sure.
Ben just entered the chat and said cheap HRVs sometimes are limited to foam filters without upgrade routes available. So if you look for an HRV unit with an optional upgrade to MERV 11 or better filters, that should deal with the smoke. Foam filters aren't sufficient.
All right. Thank you for that input. Lifetime on tapes for air barriers. I don't know any of those offhand. I know that they're going to be very different for whichever tape you're using. So on Francois's job at Dirk's place, he was using some proprietary tape that came with the air barrier essentially, and was used for very specific aspects of the air barrier, whether it was connecting air barrier to air barrier, whether it was connecting air barrier to foundation, whether it was connecting air barrier to windows and doors. Those are all different tapes that were used. And I can't comment on the lifetime. I can't.
I think the general answer is you get what you pay for. If you go for the cheaper tapes, then you won't get the lifetime. If you go with the expensive Seeger Swiss tapes, you're going to get a much longer life. But exactly what the life is anybody's guess.
Yeah, for example, Francois, can you comment on the cost of a roll of that Seeger tape that you're using?
Well, again, just like you mentioned, Matt, depending on the application, what kind of tape you're using, but anything between, $45 to $100 a roll, let's say 50 to 100. I think it also really depends on the condition, of where the tape is. If it's sitting on a wet foundation, if you're trying to seal foundation to bottom of wall plate, and your foundation is constantly getting saturated. Under that kind of condition, I don't think the tape would last that long. So it really depends on the condition and and that's I don't really know if there's a rigid rule on that. I think I agree with Ken on that one.
Right.
We do have, I believe, one last question, unless anyone has any more, but it's from Jessica, and she says, I had serious iced dam and water penetrated the inside wall. The roof is 3 to 12 and not accessible from the attic. Will a baffle installed from soffit going into the attic help this issue?
So what we're talking about here, you can often see in Roslyn and older homes, and it's the ice damming that occurs on the sort of the drip edge side of a roof, and there are some quite impressive ice dams that you see around Roslyn, some of the older buildings, and it's basically heat getting up through your ceiling insulation onto the roof, melting water coming down outside of sort of the heated area of your home, sort of on that like outside edge of your roof, and then refreezing and creating this big ice dam. and it can lead to water coming back under the shingles and then back into your house. And what's being asked is basically you can put these baffles in between the rafters on the underside of the roof that help airflow through your roof. So basically from your soffit up underneath the roof face and then out a ridge vent. I couldn't comment on the effectiveness of those. Ken, do you have any experience with installing those to address ice damming, Ken?
Well, I put them in my house, but I still get some ice dams on the dormer roof, the low angle roof. On steeper roofs, it work well, but you've got the sliding as well.
Yeah.
You don't have the extended. But there's no easy solution where you get the insulation narrowing down to next to nothing, and you're going to get ice dams building up.
Yeah.
No easy solution. Maybe
And
use heat tape.
And
Maybe I can comment
baffles-
on that, Matt's here. Maybe I can comment on that, you know, to me. And, you know, I feel like, you know, I don't think that it's an airtight problem. I think more than anything, I think it's the amount of insulation that you have above the top plate of your wall and how those trusses are designed. Typically in the older days, those trusses didn't have much heel. So you didn't have a lot of insulation on the top plate of your wall, and you had so much heat. So and you know, if you don't have insulation right above that wall, or very little insulation, is going to continue doing that.
There's not
I
much
just
you can
turned-
do about it.
Yeah, I just turned my video off because my internet seems to be freezing on me there. One thing about these baffles is that if you are going to add insulation to your ceiling blown in, you'll want those baffles installed prior to doing that, so that air is able to flow through, like along the underside of your roof, in that new blown insulation isn't pushing right up against the roofing. So that's one thing about installing those, and where they definitely come in handy. Any other questions there, Mario?
Nope. Not that I see, and if I'm missing any ones, please just raise your hand and we can look a little harder. Oh.
Soffit
Yeah,
venting.
there's some comments on the baffles. Baffles
Yeah.
need circulation, soffit venting important too.
Yeah, so if you have the way a roof breathes is you have air coming in underneath the soffit, in through the soffit, and then out through a ridge vent. And so if you don't have a ridge vent, then you're not getting that proper airflow. And if you don't have an effective soffit, you're not getting that airflow. So both of those things need to be operating properly in order to get that air pressure for that air to flow through, and help get proper ventilation in your roof. All right, well, if there's nothing else, I'll call it here. Thank you very much, Ken, for joining us again tonight and being part of the panel. And thank you, Francois, for sharing some of your experience with us. Again, I'll follow up with an email with some articles and some resources to dive deeper into these subjects. And I will dig into a few of the questions I wasn't able to answer to try to, if I can't answer them, provide a direction for people. And we've got our next talk is going to be on 2 weeks on Wednesday. I don't have the dates in front of me, but we're going to be covering insulation in windows in that talk. So yeah, join us again then to hopefully learn a little bit more about that side of home energy retrofits. Thank you, everybody.
Thank you.